Hello and welcome to Tribe Topper. In this video, you are going to learn about forces for the course of IBHL Physics. So first of all, let us define what is force. In layman terms, we can simply say force is a push or a pull. But what all things this push or pull can do? That means they will be as the effects, right? So we can say a push or a pull, which can set up a stationary body into motion, or it can stop a moving body, and of course it can change the speed of a body. It can either increase the speed of a body if it is applied in the direction of motion, and it can decrease the speed of a body if it is applied in a direction opposite to that of the body. So change in speed of a moving body. So a push or a pull which can stop a moving body, which can start a body at rest into motion and change the speed of a moving body. Newton, in order to explain the relations between how a force is applied and how the speed changes, how the motion changes, he established three laws which we call as Newton's laws of motion. So let's discuss the Newton's laws. The first law, Newton's first law, as we all know, there are three laws of Newton. The first law says that an object will not change its state of uniform motion or its state of rest unless a force acts on it. As you all know that if there is a table lying here at rest, it is not going to set up into motion on its own unless you push or pull it. And if there is a ball rolling on the ground, it will keep on rolling if nobody stops it. Even if that thing comes to your mind that you don't stop it and the ball stops after some time on its own, there is an invisible force of friction acting there. So if friction is not there, the ball would never stop. So this was first law, that nothing can change its state, whether it of rest or of uniform motion, unless a force acts on it. Right? This is also called law of inertia. Inertia, because inertia is actually the ability of a body to resist any change in its state. So we say inertia is the ability of a body to resist any change in its state. Like if you want to push a body into motion, it immediately doesn't move, it resists it. If you want to stop a moving body, it immediately doesn't stop, it resists it. But of course, if the things are lighter, they will change the states quickly. But if the things are heavier, they change the state with greater difficulty. So inertia in a way also is measured by mass, we can say. So mass is also called as measure of inertia. So inertia is measured by mass. That means heavier a body, greater will be the inertia for that body. And this law, the first law, is also in fact talking about inertia, that nothing will change any state on its own. It has to be acted upon by a force. Now let's talk about the second law of motion. The second law of motion given by Newton says that rate of change of momentum is directly proportional to the applied force. So let's say there is a body of mass m, and if you push it, suppose it was initially moving with the velocity u. When you apply a force F, this ball, its velocity, or the body, its velocity changes to v. The mass will not change, but the velocity will change, of course. And suppose the change happens in a time interval t. So we are saying if the force is greater, right? If force is large, the change is going to happen be, the change in speed or velocity is going to be quicker. Right? So that means greater the force you apply, faster will be the change happening. Like if one of you is pushing a car and three of you pushing a car, obviously you guys will produce a different impact. So that is what Newton said, that if you have a greater force applied, the velocity will change faster. Right? So that means the force applied is directly proportional to the rate of change of momentum, means the change in momentum over time. Now, how do we find change in momentum? Change in momentum will be the final momentum, that is mv, minus the initial momentum mu. I am supposing here that you already know what is momentum. If you've forgotten, just for your knowledge, momentum is mass times velocity. So if we say the initial velocity was u, so the initial momentum was mu, and the final velocity was v, so the final momentum is mv. So pf is final and minus initial momentum. This gives us the change. So therefore this leads us to f is equal to, of course we always add a constant k, but in this case your constant k is 1. So f is equal to delta p by delta t will be written as mv minus mu over t. And as a rule of maths, you can take out the common factors always out. So v minus u over t. And I hope you remember v minus u over t is a. This tells us that force is mass times acceleration. So the second law is also stated as force is mass times acceleration. So in a way, second law gives us a definition for a mathematical definition for force. So first we define force as a push or a pull, but now we say that force is, and mathematically it is expressed as mass times acceleration. This gives us a very important information that if the resultant force acting on a body is 0, there cannot be an acceleration, right? Mass times acceleration would be 0, which means, of course, mass of a body cannot be 0. So what is 0 then? Acceleration will be 0. So no force. Sometimes we say no force, or I have used the word resultant force. Why? Because sometimes there might be a lot of forces acting, but their resultant is 0. Like for example, if I have a block, one is pushing from here and one is pushing from here with an equal force, the block will not move, right? So the resultant of forces is 0. So if resultant force is 0, the acceleration would be 0. And if your resultant force is non-zero, then acceleration will never be 0. Acceleration is always there. So you have to remember that I would say, hence, whenever there is a force, there is an acceleration, right? So if some net force is acting on a body, the acceleration will be there. And on the other hand, whenever there is no force, or I will say in the absence of any force, or in the absence of a net force, your acceleration is going to be 0, which means the body would keep on moving, will move with a constant velocity, right? So if no force acting, velocity constant, acceleration 0. If a force is acting, then velocity changes and acceleration is non-zero. Further, Newton's second law also leads us to another important term called impulse. It is called the impact of a force. Now, we just said F is equal to the change in momentum over time. So, if I just cross multiply these two, that's force into time, which is equal to the change in momentum, then this quantity is given the name of impulse. So, if we want to find out the impulse, and in the question the force is given and the time of contact is given, you can find the impulse as force into time. Or sometimes they give you the initial and final velocities, then you can find the impulse by change in momentum. Here I would just like to remind you, most of the times they give you a question where a ball is moving to the right and it collides with the wall, its velocity would be v, and then it bounces back with the same velocity, but just remember to change it to minus v. And so in that case, your impulse is equal to change in momentum. So you would say it would be final velocity or final momentum, that is minus mv, minus initial momentum, that is minus mv. So it becomes minus 2mv. Sometimes you make a mistake of writing it as mv minus mv and you give it an impulse is 0. No, because the direction changes, so it's going to be negative 2mv. For convenience, you can keep the velocity while going to be negative and coming back to be positive, so you get a positive impulse because it's just going to be a positive quantity. But that's basically representing a change that is happening in the momentum. And the last but not the least, the Newton's third law is that every action has an equal and opposite reaction. So if I have two bodies, one body exerts a force on the other as F12, then it experiences an equal and opposite force exerted by 2 on 1. We put a negative sign here just to indicate that they are equal and opposite. So forces will exist in pair. So from here you have to remember that if you are standing somewhere, you exert your weight W as an action, and in turn you receive a normal reaction N upwards. So your normal reaction is always equal to your weight, which is mg. But this is true only when you're standing like this on a horizontal platform. Do not mix it with something when it is happening on an inclined plane, because sometimes what happens is, like if there is a block, weight always has to act downwards, vertically downwards, but the normal reaction has to be normal to the surface of contact, so it will go this way. So the normal reaction will be this. And in that case, if you remember splitting up of the vectors into components, so if theta is the inclination, then this weight would have its component W cos theta in this direction and W sine theta in this direction. So in such a case, your normal reaction is not equal to mg, but it is equal to mg cos theta. So just remember, in different situations, you have to take care of the directions, right? So this is how all the three laws, they impact a lot of equations, and you will use them, apply them in solving some numerical problems. That's all for this session. In the next video, you are going to learn about free body diagrams and a couple of problems based on that. Thank you for watching.